Good evening and welcome to tonight's TI Technology webinar hosted by Texas Instruments Australia. We are really excited to bring you IB Mathematics Standard Level and High Level Exam Preparation with Bijanna Graham and Joanna Cipriano. My name is John Blayman and I am your host for this event. I teach mathematics to year 7 to 12 students at Lachlan Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And I'm very excited to introduce our first panelist this evening, Miss Bijanna Graham. Good evening, Bijanna.
Good evening, John. Good evening, everyone.
Thank you for joining us. As you can see, Bijanna is a very talented mathematician and a fantastic senior mathematics teacher at Wesley College in Melbourne. Bijanna likes to continually challenge herself and share her knowledge with others through key roles with VCAA, IB, MAV, Pearson's Australia, and Panoja Education. And I was thinking, Bijanna, on top of that, also TI conferences as well. You're a busy lady. Well, thank you very much for finding time in your schedule to join us this evening.
Thank you.
Also, our second panelist this evening is Miss Joanna Cipriano. Good evening, Joanna.
Evening, John. How are you?
I'm very well, thank you. Joanna has taught all levels of New South Wales HSC and IB, and Joanna's experience with TI technology supporting her peers and students epitomises what our webinars are all about, which is teachers teaching teachers. And she has taken this a step further by producing 2 iBooks which are available online. Joanna's dedication was demonstrated with her winning the outstanding, I was going to say understanding then for a minute, but maybe that's true as well, but Outstanding Supervising Teacher Award for UNSW in 2017. So Joanna, thank you very much also for being with us this evening.
Thank you.
And that's enough from me, because I know that Ms. Graham would like to educate you much more on the use of the TI-Nspire calculator in the IB exam. So, Bijanna, it's all over to you.
Thank you, John. Good evening, everyone. In my part of the presentation, I concentrate on probability and algebra, both for standard level and high level. The first question will be a discrete probability question, as could be seen on the screen. So it's a typical question, whether it's high level or standard level. The table is given and x can take values 0, 1, 2, 3, and probability x is x if some are in terms of k. So the first part is find the value of k. Then we want to find the mean of the distribution, standard deviation, and there is a conditional probability question involved as well. So we know that we need to add all the probabilities to 1, but here we come across k squared. So I will open a new document just to do it live. And if we simplify our quadratic, we can use polyroots. So we go to menu and algebra, and we are looking for real roots of the polynomial. And our equation simplified in terms of k would be 8k squared plus k divided by 10 and minus, plus, I didn't do plus, got to go back, plus k divided by 10 minus 0.525. And our variable is k. So we get 2 solutions, but clearly k as the probability has to be positive, so our value is 0.25. So what we can do, we can store this value by pressing Control store, and we'll store it as k, so the calculator remembers that this value was stored. And then we can use this value later. So if I go to my file, what I did next after this, I've entered x 0, 1, 2, 3 in the first column in the spreadsheet, and in the second column I created probability, and I actually got the value of k here, so because the calculator remembers as it was shown. And once that's done, all we need to do is we just need to do stat calculations and one variable statistics. We had one list, so our list was x, and the frequency was probability. So once we enter that, we get the values here as shown. So we have the mean value being 1.3, and if we scroll down, the standard deviation is 1.38. Interestingly, those values also can be accessed if we open the calculator screen and we go here, so we might just get the mean value separately, and we can also scroll down to get the standard deviation, which is sigma x 1.38. So this is just a few tricks how to do those questions. And then the other question was about finding the conditional probability. X is to given that x is greater than 0, which can easily be done also using this stored value of k. So just a few tricks for the students to know that they can use one variable statistics for discrete probability questions, and they will get the values. The second question is, again, probability, and that's a combination of normal and binomial distribution, and this is like more paper 2 question, so a longer question. So we're looking at the barramundi fish, and on the farm, they are normally distributed. The mean is given in the standard deviation, and the barramundi are classified as oversized if they weigh more than 550 grams. And then we have a series of questions. We take one barramundi first, and we want to find the probability it's oversized, then conditional probability again, then we select 2 barramundi, and assuming it's independent, find they are both oversized. Then 20 are selected, so here we go now into binomial distribution, and students need to recognize that and find the mean and the expected number and the probability that at least 2. And then the last question is looking at the wild barramundi, and we are given 2 conditions, and we need to find the mean and standard deviation for those questions. So again, if we just try to answer the first one, finding probability, it was greater than 550. So we need to go to probability, number 5, distributions, and we're looking at normal CDF. This time, the lower bound is 550. So the higher bound, we can go 1 EE99. That's typically what we do on a calculator. And the mean value was 400, and the standard deviation was 60. And we press enter. So the probability is actually as displayed to 3 significant figures. This question will come up later also. So what we can do again, we can store this value as P later for binomial and also for further calculations which were with conditional probability. For conditional, we needed to find that it was greater than 600. So if we just recalculate here, and then we need to divide by this probability which we already calculated. So that will be the answer to the conditional probability. Then if we select 2 barramundi, we just need to do P, which comes bold because we already calculated it. So that's the probability that 2 were oversized. Now going into binomial distribution from here, and our p-value is already remembered on a calculator. So firstly, if we want to find the mean, so we need to go 20 times p, and that will give us the mean value. The probability is very small, so the mean comes quite small. And then we go menu probability, distributions, and this time we want binomial CDF. So the number of trials is 20, and here we can just put our value of p, so it will be quite accurate. And we want greater than 2, so we go from 2 to 20, and we are getting this probability. So going back to the question, now we have the hardest part when we know that the length, again, of the wild barramundi follow normal distribution, 10% being longer than 1.8 and 5% being shorter than 1.1. So what we need to do in this question, firstly, we need to find the corresponding Z values. So we need to go menu, and we need to go probability and inverse normal. And we had two areas. One area was 0.9, so we need to find this value. And I would store this value as Z1, so the calculator remembers this. And then we have the second value for 5%, so we need to change that to 0.5. And again, I will store this as Z2. So the next part of this question will be actually forming simultaneous equations. And interestingly, it's a very important thing for students to understand that when we use linear solve, which of course comes from solve system of linear equations, and then we have the possibility here to change to mean, and I call that standard deviation D, so that's what I did, and we just enter two equations. We need to remember that the equations need to be entered in a linear format, so we can't really go x minus mean over d equals z1, because the calculator will not recognize this form as linear and will not do it. So that's quite a good hint for the students to know. So those two questions were both standard level and high level. The next question I prepared is the Poisson distribution question, which only applies to high-level students. So for this question, we know that X follows Poisson distribution with mean M, and we want to find the value of M given that probability X is 1 plus probability X is 2 equals probability X is 3. So again, students will have to actually use the formula to write this equation using the Poisson formula and then simplify it. We know M cannot be 0, so we can divide by M, and again we get a quadratic equation. So we need to solve this quadratic to find M, and second part is asking to find the mode of the distribution. So let's try to solve the quadratic again. So we need to go menu, algebra, and we want polynomial tools, real roots of the polynomial. And our equation is, we can enter m squared divided by 6 minus m divided by 2 minus 1, and we are solving for m. So we get two values, but of course m has to be positive, so what we can do, we can copy this value, and we can also store this value as m value on the computer. Why do we need that? Because once we store that, we can answer other questions in case there are other parts. But also what we can do, we can enter our values using just m and x in the spreadsheet. So for x values, I actually went quite up to 10, but as we can see, probabilities become really small. But for the Poisson, we just go to statistics and distributions, and we this time use Poisson PDF from here. And the way to enter it, it is as the syntax here, m, which we already saved, and x. The calculator will ask whether it's a variable or the column number, so we just need to answer variable. Students do find this type of questions in the exam, find the mode of distribution quite difficult. If we scroll down, we can clearly see that mode is 4, and because the mean is 4.37, we also know that mode is the integer part of the mean, but not all the students are aware of this situation. So that's the highest probability. And also, to confirm it, we could use list as well, Poisson PDF, to list the probabilities. And if we just go to 4, we can see it's over 0.5, so we can't have any higher probability than 0.19. So 4 is indeed the mode of the distribution, but the students are expected to actually not only state the value but justify, and either drawing this table, supported also by some of those justifications, are requested during the exam. Next question is the question about continuous distribution. So we have the waiting time. It has some other context before about parents waiting for the students their basketball training, and y is probability density function, which is defined here, and time is measured in minutes. So find the probability to 4 decimal places that the parent will wait no longer than 10 minutes. Find the median waiting time correct to the nearest second. So, of course, we need to use integrals. And for the first one, we just need to enter the equation and solve. I prepared that because entering is a bit hard when presenting. Now, the other part is if we want to solve for m, we use menu algebra and we numerical solve. And then to get the integral, we just use the integral here. It is important to have it entered properly. As can be seen, after we enter up to here, we need to press tab to get dt. And if we don't put the condition that m is greater than 0, we'll get the negative value. So we need to put this condition to find the median value as 6.71. To the nearest minute, we need to subtract 6 and multiply by 60. So it will be 6 hours, 43 minutes to the median time to the nearest minute. I also have another screen here, find the mean waiting time. Interestingly, if we look at the function here, so of course we know that it is t is greater than 0. The non-cast calculator will not allow us to put infinity on the top, but putting any big number, so here like 1 million is sufficient, will actually result giving us the mean value. We can't put 1 in 99, it doesn't work, so it's a bit tricky, so it's also good for the students to realize that those questions need a bit of practice. So that is an example. Yes?
I was just thinking about that question that the students probably reading that if it was an actual exam question thinking, geez, my parents don't wait that long.
Thank you,
John. It's a bit of a controversial question, I think, to put in a test may put them off a bit.
Okay. So I continue. I have questions on algebra now, so I selected one on sequences and sigma notation. Again, this one applies both to standard level and high level. So we have the first term of an infinite geometric sequence is 4. The sum of the infinite sequence is 200. So we need to find the common ratio, the sum of the first 8 terms, and the least value of n for which the sum as n is greater than 163. So if we enter the calculator screen, so for the first question, again, we would use numerical solve, and we need to enter the equation. And the formula sheet gives the equation 1 minus r is equal to 200, and we want to solve for r, so the r value is 0.98. To find the sum of the first 8 terms, we could use the formula, but we can also use the sigma, which is available in the press to test mode, and it is definitely the easier way of getting the sum. And we want the sum of the first 8 terms, and here all we need to do is to enter the general term for the geometric sequence, which is u1 times r to the power n minus 1, n minus 1, and enter, and we get the sum. It, of course, won't be a finite number, so we would need to give the answer to 3 significant figures, 29.8. Now, the last question was asking, find the least value of n for which Sn is greater than 163. So this question is usually causing some problems. So if we start with, again, numerical solve, so we would need to, using the formula, enter the equation 4 times, and we need to go 1 minus 0.998 to the power of n, and we close the bracket, divided by 0.02, 1 minus r is equal to 163, and we're solving for n. So we get 83.5, and now students usually don't know which way to go, because the sum has to reach 200, so we have to go up, but it's not always obvious. So what can be done in this question, we can actually enter the graph screen and use the graph entry as the sequence. So I have the simplified form here, which is 200 times, this is the sum, so we are graphing actually the sum of the sequence, times 1 minus 0.9 to the power n, and close the bracket. So, of course, it will not show much, but what we need to do, if I now press Control-T, I will see all those partial sums, and it takes a while, but it's actually quite quick to get to 84 and 85. So if for 84, it's only one is that, so we need to see which number it is. We need to go to 85. So that's one of the tricks which can be done using the entry as in graph screen sequences. So 2 more questions. One is on binomial expansion. Again, that's both standard level and high level. So we have the expansion here and here, and we know the coefficient of x to 5 is 11,880, and we want to find the value of a. So we do need to, students need to simplify, but once they get to this form, which can also be written a cubed. So again, numerical solve will be helpful here. So if we go numerical solve and a cubed, and here we can go times, and if we go menu probability combination, so we had NCR 11, comma 2, so that's our combination times 2 to the power of 9, and all that was equal as the coefficients only, and we want to solve for A. We get a decimal value. If some numbers might not be as simple as this one, we can approximate to fraction, which of course is 3/4. So that's one of the questions showing that in numerical solve you can also incorporate some other features of the calculator. And my last question is on complex numbers. That's just high-level question. Given that z is 2 plus I and w 3 minus 5, I find the modulus and argument correct to 4 decimal places. That can be done in various ways. So I'm running a bit out of time, so I just show what I've done. I assign the values to z and w, 2 plus I and 3 minus 5i, and then I might just find this. Of course, I don't have to do it. I could simply say that what I'm looking for here is I want 2 plus, and it's very important to get I, of course, from here, not just typing I, divided by 3 minus 5I. And the calculator gives the exact value. If I now want the modulus or angle, so polar angle, and if I go here, I get the polar angle, and I can get as many decimal places as requested. And if I go to number and complex numbers, I also can find the magnitude of this number, which of course will only be a decimal. So if we actually want to get the magnitude as the exact value, the students would need to do this on the calculator, and then as the final step, take the square root of 5/34 just to show it in the exam question. Just quickly on complex numbers, of course, we have also convert to polar, and we can convert to rectangular. And the other thing about complex numbers in algebra, in polynomial tools, sorry, once again, we need algebra. In polynomial tools, we have complex roots of a polynomial. So let's say I will enter z, here it will not work. I need to enter x cubed, because I already had that saved, plus 1, comma x, and I will get the values. If I now wanted to change that to polar form, I can actually go to complex numbers, convert to polar, and it will give me Euler's form. The angles cannot be seen easily, but if I change the settings to degrees and say OK and repeat that again, then I can see that it is -1, 1/6, minus pi on 3, and 1/6 pi on 3. So that's what I prepared, and now to you, Joanna. Thank you.
That's fantastic, Biljana. And I think that there's lots of information there and questions not only for teachers to share with their students and to learn from, but also to actually get their students to use. So like I said, this resource, once it's available on the TI website and on our YouTube channel, will be fantastic for everyone to learn some fantastic ways of answering some of these questions with a knowledgeable person like yourself. So thank you very much.
Thank you.
Okay, Joanna, I can see your screen. It's all yours.
Okay, thank you. Tonight I'm going through some SL and HL questions, exam style questions on functions and calculus. So here's the first one. It's actually from an SL exam. It says let fx equal 6 minus log of x squared plus 2. X is in real numbers. The graph of f passes through the point P4 where P is bigger than 0. Find the value of P. So basically I want to know for what x value does all of this equal 4. So I can do that using Nsolve. So if we open a calculator document on calculate, menu, algebra, Nsolve. Okay, so I want to know when 6 minus ln of x squared plus 2, and get out of there, and then I want to know when it equals 4. And I want to tell the calculator to solve it for x. Okay, press enter, and I get 2.32, and so that's the value of P. That's the x value that gives me 4, so that must be the value of P. Okay, the following diagram shows part of the graph of f. The region enclosed by the graph of f, the x-axis and the lines x equals negative p and x equals p is rotated 360 degrees about the x-axis. Find the volume of the solid form. So we can do this by doing a definite integral for volume. Okay, so we can do that by pressing this little button here and choosing an integral. And I want to go from negative p to p, so I'll put them first. Negative 2.32 up to 2.32. Okay, but wait a minute. A volume has pi on the outside and it's y squared inside. So let's get out of the integral and put pi there. So put pi and then times, and then I've got the integral. So let's get back inside and put the function, but I need to square it. So we'll do brackets, 6 minus ln x squared plus 2, close bracket again, and I want to square all of that. And I'm integrating it according to x, enter, and my volume is 331.846 when it's rotated. Again, that's it for that question. Question 2. Let hx equal all of this. Say x is between 0 and 4. The following diagram shows the graph of h and the line y equals x. So look down, there it is there. The curve is the graph of h and then y equals x. Now, the graph of h intersects the graph of h inverse at 2 points with x coordinates 0.111 and 3.31. Now, as we know, that actually means those are the x coordinates where h intersects the line y equals x as well. And I want to find the integral from 0.11 to 3.31 of hx take away x. Now, we can do it using definite integrals just like we did in the last question, which is absolutely fine, but I thought I'd show a different method. And what we need to realize that there is actually would give the area between the curve h and the line y equals x, in other words, the bounded area. So we can do that on a graphs document. So if we press on graphs, and we're going to graph our two functions, I might use a shortcut by copying and pasting. I'm going to copy that and paste it there. And I better put a times in here because it's a little bit funny about that, and I might even put a times in here. Okay, enter, and there's my h, and I better graph the line y equals x. So I'll press tab, just x, enter. Okay, so I want to find the bounded area in between those two curves. remove that. Okay, so we go Menu, Analyze Graph, Bounded Area. And when I choose my lower bound, I'm going to put it right on that point of intersection and see how it says intersection point, so you know you're at the right point. Now for my upper one, I'm going to do it again right on the point of intersection. And there's the area there, 2.72, which is also equal to that integral there. So that integral, it actually equals 2.72. Okay, done. Hence, find the area of the region enclosed by the graphs H and the inverse of H. Well, hopefully we know that the inverse of H will be the reflection of the blue line across y equals x, which will then give a mirror image, and therefore the new area will just be double this area that we already found. So, to answer this question, we just do 2 times 2.72, which is 5.44. And that's the area of that. Now, let D be the vertical distance from a point on the graph of H to the line y equals x. There is a point AB on the graph of H where D is a maximum. Find the coordinates of P where A is between 0.11 and 3.31. So in other words, according to our graph, A is between these two intersection points, the x values. Okay, so for somewhere here, the vertical distance is at a maximum. So what we can do, by opening a new graphing document, we can graph the function of D, which is hx minus x. So, here's hx again. There we go, copy. Tab, okay, there's hx. Oh, I didn't want to. Okay, there's hx, and I want to minus x, and then that gives me the function of D. Let's put a couple of times in. All right, so this is the function of D now. Enter. And look at that, it has a clear maximum point here. So let's find what the coordinates of that maximum point are. So Menu, Analyze Graph, Maximum. Okay, lower bound, upper bound, and there it is there, 0.974 and 1.3. Now, it's important to realize that the x value 0.974, that is the value of A that we wanted. Okay, so, and it is between those two values there. So we found A, but we haven't actually found B, because B, this point here, is on hx, whereas this graph here is a different function, it's hx minus x. So that value is actually kind of meaningless. It's actually the maximum distance. So we've got our x value. To find B, we want to find h of, like, substitute that into h. So we can do that on a calculator document. Okay. Good. Here's h again, but I'm going to throw in our value of A, which is 0.974. Okay, times cos of 0.1 times 0.974. So I'm just putting the A value into H. And there we get our B value, which is 2.2697. So the coordinates of point P are 0.974 and 2.27, so very significant figures. Okay, done. Question 3. Here's a function here where x doesn't equal 1 for the graph of find the x-intercepts. So let's graph it on a graphing document. Okay, so it was 2x minus 6 over 1 minus x. So let's just control that to get a fraction. So it's 2x minus 6 over 1 minus x. Let's have a look. Okay, there it is there. So to find that 0, I'm just going to move this. To find the 0, menu, analyze graph, 0, or in other words, the x-intercept. Here's my lower bound, here's my upper bound, and there it is, 3, 0. So the x-intercept is where x equals 3, or the point 3, 0. Write down the equation of the vertical asymptote. Now, hopefully the students can just look at this and realize, oh, fx is undefined when x is 1, so therefore the vertical asymptote is x equals 1. Or they can look at this and maybe zoom out, so menu, window zoom, out. You can just zoom out a bit and hopefully see it looks like it's at x equals 1. But if they can't do any of that, what we could do is this. We can get menu, table, split screen table, and we can actually see, I'm just going to press escape to get out of the zoom. We can see that our function is undefined when x is 1. Therefore, the vertical asymptote must be x equals 1. So it's right there for us. So this here is x equals 1. And now find the equation of the horizontal asymptote. So hopefully with their understanding of functions, that as x approaches infinity, we approach the horizontal asymptote. Now what they can do there is just scroll down. As x gets bigger and bigger and bigger, which is in the downward direction, if we just keep going down, keep going, okay, so at the moment, x is 67, and we're at negative 1.93939. Okay, keep going. And as we can see in the highlighted cell, we're just getting closer and closer to negative 2. We're not quite reaching it, but we're getting closer and closer. Therefore, the horizontal asymptote is at y equals negative 2. And that's done. Okay, here's our first HL question. It says find the equation of the normal to the curve that at the point where x equals 0. Okay, so we want the equation of the normal. Now, I'm actually going to use a graphing document. So I press on, graph. Okay, and I'm going to graph that function, but I'm going to cheat. I'm going to copy it. There we go, copy. Tab, okay, paste. Oh, I don't want to. There we go. Okay, now let's throw in some timers just to make sure it all works. So put a times in there, and a times in there. Enter. Oops, apologize. Oh, I apologize. I'm going to get out of that. So what went wrong there? It just read it as variable e, not the actual e. So I better do that again. So if I press tab, copy, paste. Now I'm going to do this e. So that there should be this e here. E to the x. I better get rid of that. Okay, that's better. E to the x times cos of x times log of x plus, and now we better delete that. Put in e. If I just want e, I'll put it to e to the 1. Hopefully that'll work. It did not. Okay, I'm going to try it one more time. I might just type it myself. I think that might be best. So tab. Okay, so it is, just a second. Okay, e to the x, get out of there, times, we'll go trig, cos of x, get out of that, times log of x plus e to the 1, x plus e to the 1, and get out of that, over x, oh sorry, I need brackets, x to the 17 plus 1 to the 5. All right. Now, it's pretty strange looking function.
Well done, Joanna.
Thank you. I persevered. Now, basically, we want to find the equation of the normal where x equals 0. In other words, this little y-intercept right here. So, first, we can find the derivative at that point. So, if we go menu, analyze graph, dy dx, and then we're going to get it right on this little intersection point. And you can tell we're on the right point because it says intersection point. Okay, so that is our gradient, but it's the gradient of a tangent. So I'm going to open the calculator document to get the gradient of normal. That'll be -1 divided by, that's 1.37, to find the gradient of the normal. So there it is there. Now, as we know, the equation of a line can be y equals mx plus b, where b is the y-intercept. The good news is we can see that right there. It's just at 1. So the equation of our normal is y equals -0.73. X plus 1, and that's the equation of our normal. Okay, calculus 2, consider this function. It's a very long one. Now, in the actual exam question, it asks for the derivative in one of the parts. I've just written it there for us to save us time. Now, after we found the derivative, it says find the coordinates of the points of inflection of the graph of y equals fx. Now, I don't really want to differentiate that again. So what we can realize is the points of inflection, they're hard to see on F. But what we could do is just find the stationary points, of f dash x. So graph f dash x and then find the stationary points of that. So the x-coordinates of the stationary points of f dash x would be the x-coordinates of the points of inflection of fx. So let's try that. Just going to copy this. We'll see if it works this time. Okay, so let's open a graphing document. Tab. Okay, here it is. So it's 4 times sine x, oops, wait, yep, that's right, times, sorry, I'm going to just do it from scratch. 4 times sine x times cos x. 1 second. Here we go. Plus 14 times cos 2x plus 6 squared x. Oh, there. Okay, and let's just put brackets around that and then square it. Okay, now that's a pretty scary function. But the good news is we only want it from where x equals 0 to pi on 2. So let's restrict our window. Menu, window, window settings. Okay, so let's put 0. And then here, we'll put pi divided by 2. Okay, let's just see what that looks like. Much better, but I can't see the top here, so let's expand our Y. Menu, Windows in, Windows settings. Okay, let's get that Y max to like 20 or something. All right, there we go. We can see that there looks like there's a max here and a minimum there. So let's find those. Analyze graph. Okay, we'll go minimum, lower bound, upper bound. There it is, 1.13. And the maximum. Okay, we'll get to as close to 0 as possible about there. And over here, yes, there is a maximum at 0.074. So the x-coordinates of the points of inflection are 0.074 and 1.13. Last question, we might have typed, a particle moves in a straight line such that its velocity v is given by this. Find the value of t when the particle is instantaneously at rest. Oh. Basically, no, I apologize. That should have said, the particle is at rest. It's actually when t equals 6. So that's not so much a calculation. Now, what happens then after t equals 6, the particle returns to its initial position at t equals capital T, so find the value of t. So in other words, for the first 6 seconds, we're moving in one direction, and then we move back to the origin. Its initial position. So what we want to do is we want to know how far the particle moves for the first 6 seconds. And then, so that's our first step, put it that way. Okay, so let's do that. So let's find for the first 4 seconds, that's the velocity. So to find the distance it traveled, we need to integrate it from 0 to 4. So it's an integral from 0 to 4 of 5 minus brackets t minus 2 squared. Okay, and it's dt. Now, I need to get out of the integral, and I'm going to add, so what happens in the next 2 seconds? So we need to do another integral from 4 to 6, and this time the function is 3 minus t on 2. Okay, and we go dt. Okay, so that there is the distance it traveled. So now I want to know how long it takes to come back to travel that distance again. Keeping in mind, from now on, the velocity is only defined by this after 6 seconds, even after 4. So what we want to do now is we want to go menu, algebra, numerical solve, and we want to know when the integral equals 15.6667. So what we can do, first of all, this function is actually going to go under the x-axis, so the area or integral will be negative. So let's take the absolute value. And then we're going to put our integral in there. Okay, so it's from 6 seconds to, I actually don't know, that's the unknown, that's a capital T. I'm going to put x in though instead of capital T, because the calculator will get the capital T and the lowercase t confused. Then I'll put my function in, 3 minus t on 2 dt, and I want to know when all of that equals 15.6667, comma, and I want to solve it for x. Now, that's at a negative number, but time can't be negative. Oh, so that must mean there must be 2 values. So what we're going to do is we're going to grab this function again, but this time we're going to tell it. We're going to give it a bound. So press control equals here, and I want to know the value of x for when x is bigger than 6, and it's 13.9. So that means it takes 13.9 seconds altogether to travel all that distance and back. So it's at 13.9 seconds that we return to the origin. So that's the value of capital T. And that's it from me.
Wowzers. And I have to say, I think you chose some of the longest equations I've ever seen, I think, just to really challenge yourself this evening.
Yeah, as you can see, I did, yes.
Yeah. Oh, there's somebody's phone trying to ring somebody. That's an interesting call going on in the background there.
Yeah.
So I'm just going to share my screen just to bring it home. And thank you very much for that. I was just looking at the TI Australia website. Obviously, it was exam ready this evening, but there's also some fantastic resources for teachers in the senior curriculum inspirations. And if my internet's working, there we go. There's IB down the bottom here for all the different courses. So it's both the standard level, higher level, and the studies. And we can find some activities that are already available in all these different topics for people to use. And if we click on any of those, the old classic fill the vase, there's actually the TI-Nspire PDF document and the answers. So please, I encourage you to look at those at some point. All right, so there we are. That brings us suddenly to the end of tonight's webinar. We'll begin wrapping things up. So if you do have any last-minute questions, please try and get those asked. Bojana and Joanna will be watching the chat window and the Q&A window, so if you do have anything, please send it through that. I know they will endeavour to answer them, or they'll add them to future webinars that they plan for on IB and other topics. When you leave the webinar tonight, a brief survey will automatically appear here in the browser. Your feedback does guide us as we plan for future online events, so we do listen to your feedback, and we hope you do share your thoughts in a post-webinar survey. Your certificate of attendance, always important, will be emailed to you in the next 48 hours, along with a link to the on-demand and YouTube version of the recording, as well as any relevant documents that Joanna and Bojana showed this evening. And as I said, please follow those through again, share them with your students and your fellow teachers. After we leave tonight, if you do need some post-webinar follow-up, please feel free to phone or email TI Australia. I know they'd love to hear from you, and if they can answer your question, I know they'll put you in touch with experts like Bojana or Joanna. And certainly that brings us to the end of tonight's webinar. Thank you very much, Bojana and Joanna, for everything you've shared with us tonight. I and the participants have really appreciated it, so thank you.
Thank you.
Thank you.
And thank you, everyone, for joining us tonight. We do hope that to see you back online again soon, and if it's almost the end of term for you, I hope that you have a fantastic holiday. Many thanks, and we'll speak to you again soon. Bye now.